Addition, subtraction, and multiplication of radical expressions. So what we're going to do is first start with addition and subtraction, and then the second part of the video will be on multiplication. Radical expressions, as you will know, are basically expressions that contain a radical. The radical is the symbol that you see here. Sometimes you have a different index. The index is the number that's in that little v here. So in this case, this is a cube root because the index is 3. And if you don't see an index, then it is assumed to be 2, and so we have a square root. In order to add and subtract radicals, we need to make sure that we have like radicals. Like radicals have to have the same index, and they need to have the same radicand. Radicand is whatever is inside of the radical. As long as we have like radicals, we can go ahead and add and subtract. The way we're going to add and subtract for the first example is we focus on the numbers that are on the outside of the radical, which are these 3. Those are the numbers that you can add and subtract together. The radical does not change, and so we do not add the radicals together. We don't add the inside. We don't subtract the inside. We leave it as is, and that will be part of our answer. So if we're just going to, in this case, subtract, what we get for our, so basically it's just going to be 9 minus 4, and then 5, and then minus 8, so we get -3. Okay, so that's what we get, and then, like I said, the radical stays as is. Most examples will not have like radicals. They're going to have different radicals, as example 2 and 3. In this case, example 2, we don't want to just subtract 2 minus 3 because the radicals are different. One way to do this is to simplify both of these like you did earlier and see if we can end up with like radicals. So we're going to rewrite square root of 48. So I can break up 48 into a perfect square. It'll be 16 times 3. Same idea for 75. Perfect square is going to be 25 times 3. Notice that you can take the square root of 16 and the square root of 25, which is what we want. This is why I broke it up this way. 3 is going to stay on the inside of the square root, and that's going to be your like radical. So next step is I have to simplify. I need to take the square root of 16, which is 4, but I have to multiply that with the 2 that's on the outside here. So I'm going to write this out. It'll be 2 times 4 times the square root of 3 minus 3 times 5. So we get that. And then from here, of course, we're going to multiply. So we have 8 times the square root of 3 minus 15 times the square root of 3. Like radicals, I just subtract 8 minus 15. We get our final answer, -7 square root 3. Remember, the like radical will be part of your answer. Last example for adding and subtracting. So in this case, we are going to do the same exact thing. We're going to simplify each of these radicals, see if we can find like radicals. Best way to rewrite 18, you need the largest perfect square, so that's going to be 9 times 2, and then xy squared plus, for 8, break it up as perfect square would be 4 times 2. 25 times 2. Now we need to take the square root and also see what the like radical is. You can also take the square root of y squared, so we have to do that as well. It seems like the like radical is going to be 2x because that is common to all three of these. Square root of 9 is 3 times 2 is 6. Square root of y squared is y. Whenever you take the square root, whatever you get goes on the outside. 2x has to stay on the inside. Plus 2y times the square root of 2x minus 15y times the square root of 2x. We have like radicals, which is awesome. We also need to make sure that the terms on the outside, okay, these have to be like terms. Notice that these three are like terms because they all three of them have a y. If these three are not like terms, we still cannot add and subtract. So you have to have like radicals and like terms on the outside. So you got to pay attention to those two things. If this didn't, for example, if this last term was just 15 without the y, then I can only add these two together and this part would just come down as part of the answer. In this case, they're all like terms and like radicals, so when we combine, we get negative 7y times the square root of 2x. Let's take a look at the second part, which is multiplication of radical expressions. So for this last part, you want to notice that what we're really doing here is just multiplying two binomials, right? So we have two terms. So these are two binomials. This is, you could think of the second example as a binomial squared, and then this again is a binomial times a binomial. From before, if we multiply binomials together, we FOIL. So the question is, how do you multiply radicals together? You multiply whatever is inside the radical. So inside radical, radicand times radicand, I can multiply together. Whatever is on the outside of the radical, we can multiply together. You cannot multiply a number or a term that's on the outside of the radical with a number that's on the inside of the radical. So they have to be in the same place in order to multiply. So start by foiling for the first example. We have square root of 3x times square root of 3x. These are both inside the radical, so I can multiply them together. You still have to keep the radical, by the way, so that's going to give me 9x squared. Then we have square root of 3x times negative 1. 1 times anything is just going to be that quantity, so that's just negative square root 3x. Minus, now you have to multiply these two. 8 is not in the inside of the square root, 3x is. They are not in the same place. One is on the outside, one is on the inside. We cannot multiply them together, and so the only thing you can do is write negative 8 times the square root of 3x. Do not multiply these together. You will not get the correct answer. And then the last thing is negative 8 times negative 1, which is positive 8. Notice that we have like radicals, which are these two. This is kind of like a negative 1, so if you want, you could put negative 1 there. And I can also simplify the first radical. That's a perfect square. We get that. Combine here. Negative 1 minus 8 is negative 9 times square root 3x plus 8. I look at these three terms. None of them are like terms. Therefore, we stop right here. Final answer. Next example. we have a binomial squared. When this happens, remember what you want to do is write two of these. Okay, they're exactly the same, so that's why we could write them with the squared, but we want to break it up, write it twice, because you have to FOIL. Okay, so we need to FOIL just like we did for the first example. You can multiply outside numbers together, and you can multiply inside numbers together. So we have 4 times the square root of 25 plus 2 times 3, that's 6. They're on the outside. I can multiply them together. 5 and 2 are on the inside, so that makes it square root of 10 plus these two. 3 times 2, 6. 2 times 5, 10. Plus the last two terms, 9 square root of 4. Like terms right here. I can simplify the first and the last. 4 times square root of 25 is just really 4 times 5. That's 20. Plus, these are like radicals. I add the numbers that are in front. Keep the square root as is. Plus, square root of 4 is 2. Times 9 is 18. Like terms. Last example, important example, because we need to use what we learn from this last example for division of radicals, which is the next video. But this is important. What you want to notice here is that we have two binomials. However, the only difference between them is the sign. This is plus, this is minus. Everything else is the same. If that happens, they are called conjugates. When you multiply conjugates, you have a special property, and that is that the final answer will not contain a radical. Notice that in example 1 and example 2, there are radicals in the final answer. When you multiply conjugates, the final answer will have no radical. So let's see. 7 times 7, 49, x times x, square root of x squared, minus 7 times the square root of 2x, plus 7 times the square root of 2x, minus square root of 4. Look at this carefully. Like terms are 0. These like terms in the middle, they give us 0, so these go away. It's not like the other two examples where the like terms in the middle, you can combine them, you don't get 0. In this case, you get 0. This will always happen for conjugates. And the first and the last are always perfect squares. If you have a perfect square, then the radical goes away. So what we really have here is just 49x minus 2. And that's our final answer. These are not like terms, so I don't combine them. But there are no radicals here because we have conjugates.